Okay, well thank you all for coming today. My name is Matthew Groves and we're talking about JSON data modeling. So if you got questions, move on up. There's plenty of seats up here in the front. Happy to answer those. Most of you as developers are probably familiar with the relational way of modeling data. This same kind of schema here with the tables and the foreign key relationships. But if you want the benefits of a non-relational database, which I hope you do because you came here, we have to think differently about modeling. Fortunately, NoSQL databases and Couchbase in particular is going to give you some familiar tools to help get you on your way. So we're going to talk about modeling today for sure. We're going to talk a little bit about why NoSQL first, why you'd even consider making that move. We'll talk about JSON data modeling and then accessing data because that figures into the way you model data as well. I'll walk you through some examples to kind of show you the pros and cons of different modeling approaches. And if we have time, we'll get to some Q&A towards the end. So why NoSQL? So let's start first of all about what NoSQL is. I'm going to focus today on the document database part of NoSQL. It's a very wide umbrella, but we're going to focus on document databases. They originally came with a very minimal set of features and minimal API, but as they continue to mature, there's more and more ways to access that same pool of NoSQL JSON data. And generally, we're seeing some convergent trends between relational tools and NoSQL tools. I hope you'll see some of that today. But anyway, this minimal set of features, that's where you get the buzzword NoSQL, because NoSQL is not an option up there, except we're going to see kind of a reversal of that later today. So why NoSQL? There's generally, I think, 4 high-level reasons that organizations and companies and enterprises want to make the move to NoSQL. The first one is scalability, and horizontal scalability specifically, to add more nodes as we need more capacity, keep adding those additional nodes to a cluster. The second one is availability. I took this picture of my wife at a movie theater. I told her I'd put it in every single slide deck because she's demonstrating availability in an excellent way. One of the machines here is down for maintenance or refill or whatever, but we're still able to get our sodas to go to the movie because there's plenty of nodes there, so they keep the whole soda machine available. Performance is a big one. We'll talk about access patterns that can help with that. Memory usage. A lot of NoSQL databases treat memory differently than traditional legacy databases. The last one is flexibility. This is the one that I think developers are mostly interested in because now we don't have to worry about all the constraints that relational databases place on us. Now, all these characteristics go hand in hand, but I want to focus today on flexibility because that's the most important aspect when it comes to JSON data modeling. This is an example of a relational data model. You've probably all seen something very similar to this. We're all familiar with this kind of approach. This is an example of 2 tables. We've got a user table and an address info table. And to get that information together, we typically have to use a join. We have 2 different pieces of data that make up really one entity. So to present them in our user interface, we have to do a join, get that data together, and then present it to our UI. With a JSON modeling approach, we could combine that into one document instead. Now, why would I want to combine these? Let's go back to those 4 whys. So first of all, scaling. If data can be more independent, then it can be more easily stored on multiple nodes. We can store it on any one of those nodes, and we can access it independently of the other data in our database. Availability is important. When there's multiple nodes, there can be backup replicas for a quick recovery if one of those nodes crashes, goes down for maintenance, whatever. Speed. In this case, we are reducing the amount of work our database is doing. So instead of a join query, we're doing a really fast get, a quick lookup of one document instead of a join of multiple rows of data. And that can be even faster if your database has a built-in cache. But what about the flexibility part? For that, let's look at a broader picture of a relational schema here. So suppose for this schema, I want to add a column. So in this case, I'm adding a country to one or more tables. Now, in a relational database, especially a large one, adding a new column can often affect availability because it could require downtime to add that sort of column. A simple alter statement can often be 2 a.m. Saturday weekend for me, performing that upgrade on the database. Also, in this case, what if country doesn't make sense for every single row in a table? What if some are physical objects and some are digital objects? Does it make sense to put a country on a digital object? So now, if it's optional, now we've got a nullable field and potentially lots of nulls floating around in a database. I know no one's ever run into that problem before, right? Yeah? No? Okay. So that is an issue with relational databases where flexibility can really help us when it comes to a JSON database. So if we're going to make this change in a document database, it does not require an alter statement. We don't have to let the database know our intentions at all. As a developer, you can just start adding that data, country information to your data, or update existing data to add it. It does not require every document in a given collection to have a country. So this is just a minor example, of course, so just a little one field there with one string. But if you extrapolate to a schema with hundreds of tables, for instance, and often changing business requirements, which I'm sure we deal with on a daily basis, the flexibility benefits can really start to stack up. And this is why JSON document databases are appealing to developers. Now, I get asked a lot at the booth. Some of you came by the booth today and yesterday at Devnexus here, and they ask, what sort of use cases are there for NoSQL? Why would I be interested in doing that? So I work for a NoSQL company, Couchbase, and the use cases I've seen over my tenure there, over 7 years, have just been expanding and expanding and expanding into places that you may not think NoSQL would have made sense in the past. But here's a whole list of different sectors and use cases that NoSQL databases are being used. It's also worth pointing out that plenty of companies are doing most of these cases with relational as well, right? So I'm not saying never use relational ever again, but in my view, relational is usually kind of at least the mediocre choice, kind of the safe choice, but NoSQL may be better for a lot of your use cases. And usually the catalyst is one of those 4 reasons: speed, flexibility, scale, and availability. So my view on, if you're thinking about using NoSQL to make some improvements, there's the old adage, different isn't always better, of course, but better is always different. So that's why NoSQL. That's why people are, and organizations and companies are looking at NoSQL. So hopefully you're on the same page as me. You're interested in NoSQL, interested in how it can help your company, your organization, your team, your project. But let's get into some more details here, because if you come from a relational background, the idea of JSON data modeling might be a little intimidating because it's a lot different than relational data modeling. So let's start with some basics. NoSQL databases don't have tables. What do they have instead? So this can actually vary from NoSQL database to NoSQL database, but oftentimes you'll at least see a collection, which is kind of analogous to a table. It's the same kind of level of organization. But again, we don't have to define what a collection contains. It's just a list of JSON, a collection of JSON objects. They could all be very similar in structure. They could have some variation. Hopefully not too much variation. That might just be a little weird, but they'll have some variation between the documents, but they all belong to the same collection. So that's a collection. You'll see something in Couchbase. You'll see that in Mongo. You'll see that in Cosmos. You'll see that in a lot of document databases. You'll at least have a collection concept there. Collections may belong to another sort of higher level organization building block, something called like a scope. And so that's a really useful construct for things like microservices or multi-tenancy, where you want to organize collections into different areas of their own. So Couchbase has the concept of scopes, for instance. And then, of course, the collections or the scopes may belong to a higher up concept. Something like a bucket is called in Couchbase. And a bucket level is similar to your database or your catalog level in your relational databases that you're familiar with. Now, data organization can have an impact beyond data modeling. I'm not going to cover that today. We're talking about things like access control and queries and indexing. I mentioned multi-tenancy, but replication can also be an issue. I'm not going to cover those things today, but those are definitely concerns when it comes to NoSQL. So just a quick translation guide to help you. Most of you are familiar with relational. This is kind of a side-by-side of NoSQL terms next to the relational term that you might already be familiar with. Doesn't mean these are the same things. It's not just renaming things, but it's going to help you to a starting point to understand the organization level of the various terms. So from server all the way down to like a primary key would be in a distributed database like Couchbase, a cluster, all the way down to a document key. So similar concept, similar level of organization there. So I'm not here to tell you that JSON modeling is superior to relational. There are trade-offs. So just a couple to mention here. Relational databases, they require normalization. It has to be in at least third normal form, right? That's the prescriptive way of modeling data in relational. It requires alter. And there's some benefits to that sort of thing. If you want to maintain a very, iron-fisted control over the shape of your data, developers may not be happy with that, but in some use cases that might make sense. But the trade-offs are that it's difficult. Notice I didn't say impossible, but difficult to get those four things out of a traditional legacy relational database. With a JSON database, you can still have normalization if you choose, but it's a relaxed normalization. It's not enforced by the database. It's enforced by the application and database together, working as a cohesive unit. So what we want to accomplish then with modeling is to optimize the modeling based on the access patterns. So how are we reading and writing our data? Not necessarily third normal form, prescriptive relational modeling. We want to be flexible. We want to be able to respond to change. One of the tenets of agile development is responding to change. And we want to deal with clustered and scalable databases and systems so that we can, again, respond to increased demand, increased workloads. Again, not impossible with relational, but as a colleague of mine once said, when he tried to do this with a relational database, I'm not going to name the database, but he said basically, I hate my life when I do that sort of thing. Okay, so let's just go through an example real quick here. And we got relational on the left, is what generally I'm going to follow here, and then document on the right. So we've got a one table, one row, and this is going to be a theme you're going to see. We already have a decision to make when it comes to JSON. Now, decisions is opposite of prescriptions, right? So if you're not comfortable with that, JSON modeling, maybe you're not ready for that just yet. But remember that unlike relational, decisions are more easily reversed. Okay, so if we model a certain way and we make a mistake, now let's do it the other way, that's no big deal. We can reverse that decision. It's pretty simple to do. So in this case, we can model it as one field with a string. We can model it as an object with two subfields if you wanted to. Of course, you can model it as two different fields at the top level as well. Lots of options there. But I hope you see here kind of the simplistic, naive translation of relational data to JSON data. So I just wanted to start with this because it's a simple example and make sure everybody's on board before I get into the more complex stuff. It's hard for me to see nodding heads with these lights in my face, but I see a few. So, okay, now I see some thumbs up. All right, thanks down there. Okay. All right, let's get a little more complex. Let's bring in a second table. And I've got a relationship here between billing records, or billing methods, I guess, and a customer. And it's usually done with foreign keys in a relational database. So we've got a single customer now that's split up into three pieces in two different tables. So I like to think of relational data as taking my cohesive data, my entity, and putting it through a paper shredder and then storing those shreds. I have to reassemble them later. That's kind of my mental model of relational data. Now, in a JSON model, one way we can model it, one way, is to embed that billing data into an array so it remains a single document. It doesn't have to go through the shredder anymore. So you can see now we've got three pieces on the left and one piece on the right. Now, if you have a use case where your data access consists of querying customer joined with billing data, and that happens a lot, this will lead to better performance immediately because we've reduced this from a join or potentially multiple lookups into one single quick lookup. Okay, and last one here is orders details, and products. So in the JSON database here, we've got it can be a customer's collection. I mentioned collections earlier. It can be a products collection, orders collection. So we can still organize those into different table-like structures called collections. But again, it's back to decision time. Do you want to embed those order details into an order document? This could be better performance. as well as more flexibility. But it's a decision you have to make. Whereas the third normal form, the decision is already made for you. You have to put it into a separate table. So I presented you options here, and with options, there's always trade-offs. So that's always the lame answer to anything, right? It depends, but it's just the reality, right? So there's lots of trade-offs. I'm going to walk through a few more examples later. We can see some of those trade-offs in action. But data modeling is all about trade-offs. Consolidating data into a document, it means that document could get big. We could have a big piece of data now instead of a bunch of smaller pieces of data. Atomicity. If you consolidate, you have less need now for ACID transactions. And if you don't or can't consolidate, there's still ACID transactions, but they're more overhead now, especially in a distributed system that brings the network into play. Complexity. The more normalizations, the more collections we have, that could be more complex for us to manage. But small collections can have indexing benefits. So back to a performance trade-off versus complexity. And then speed. Document size is one factor of speed. More on that later for sure. But we want to make sure we optimize for access patterns here. We'll talk about the different ways you can access data. But for document size, for most NoSQL databases, a single document is limited in size. So don't quote me on some of these. I think Cosmos is around 2 megabytes, depending on which API you're using. Mongo is 16 megabytes. Couchbase is 20. So there's a cap there. But the point isn't the actual cap. It's that large consolidated documents that approach those caps have trade-offs. If the size proves to be a bottleneck, then break them up. Right? But until then, I would say prefer to consolidate as much as possible would be my guidance there. Speaking of breaking them up, another decision exists when it comes to relationships, the embed versus refer. Again, the relational world, it's always refer. It's always foreign keys, separate tables. In the JSON document database world, you can choose. So here are some tips to help you decide which way to go. For each of these, not all of them may apply to every situation. So for example, in an embed when entity A owns B, and A and B are often accessed together. And you're mostly reads. And the combined data is relatively small. So those are kind of three or four things to follow where it makes sense to embed. But you might want to refer, have separate pieces of data if A is related but doesn't own B. So some sort of aggregate root concept, if you've read the domain-driven design book before, that concept kind of applies here to modeling as well. And in that situation, if both docs are accessed separately from each other, not together, but separately in certain cases, or there are often a lot of writes. If I want to update individual piece of that document, I want to have it split out. So I'm going to be writing to that one and leaving the other one alone. Or if the document size needs reduced, I want to split it up as well. So, but my recommendation is, again, when in doubt, embed, consolidate first. That's just kind of the rule of thumb with JSON modeling. Here's a model to demonstrate some of the relationships you got to think about. There's the one-to-one, there's the one-to-many, which can also be embedded. There's the many-to-many, so in that situation, it still makes sense to have these separate. In this case, instruments could measure multiple satellites, and satellites are measured by multiple instruments. So it makes sense to keep those apart. And then like in the relational world, there's a many-to-many collection of measurements that link them. All right, so that concept still kind of applies, that mapping table you might have used before in relational world. Okay. Now, one of the things I get asked a lot is, Matt, if I can just keep adding fields to the documents as I go, well, how do I keep track of the change to my documents, the change to my structure? And so there's lots of ways to deal with that. Again, lots of options in the document database world. So we're talking here about versioning between different iterations of your document. So one approach is to simply put a version number in there. So version 1 has name as a single string. Version 2 has it broken up into 2 different strings. And then in your application logic or your backend or whatever, you can then have some logic around the version number that treats your documents differently. So that's one approach you could definitely take. Another approach is to just called the Big Bang model. Just change everything to the new model. A big update, or more likely a series of batch updates. Right? You can take this approach with relational as well. Right? If you need to make a change to a relational model, it's the big alter statement. That's kind of a Big Bang update sort of thing. A third approach, and this is one I find particularly cool, but it does take a little bit of effort, is I'm going to call it cooperative reversioning. And let's say a web application accesses a piece of data in the course of normal operations. But while we're at it, we've got the data, we've got the key and everything. Let's go ahead and change the format of that data. So as people keep logging in and using the system, it gradually migrates that data from the old format to the new format. Now, this is an approach that relational will be very difficult to pull off because it gets messy. You're going to end up with a name and a first name and a last name column all at the same time, and a lot of nulls. And again, I've seen this in action before. It's messy, it's unpleasant, but it is possible. With a document database, you don't need those nulls hanging around. Once you convert one document over, you don't need the old one anymore. So you can do it on a per document basis. And you can use all three of these approaches together if you'd like. You can have a version number and cooperative remodeling, and you could try a Big Bang every month or so if you wanted to do that sort of thing. There's probably better approaches as well. If you've all used this before, if you have better approaches, please come talk to me after, and I'd love to hear about them. And one more thing that's important, if we're going to go through multiple changes to our data structure, it's important to keep our team all together and on board with this modeling. So there are some great tools out there that can help. You may have heard some of these brands before, but these are ones I've picked out that have NoSQL features available as well. So Hackalade's a great tool, supports lots of NoSQL databases, document databases. Irwin DM also supports multiple NoSQL databases. Or you can just keep it real, no frills, free offering. There's JSON-editoronline.org, which maybe you laugh, but it's actually a pretty sophisticated tool for collaborating around JSON data models. So you can start with one or all of those tools, especially if you have a large team that needs to be on the same page when it comes to the model. You can check all of these models into your source control. Okay, so I hope I've given you something to think about when it comes to modeling relationships, but there's one more important key factor when it comes to deciding how to model your data, and that is how we're going to access the data, because that can affect the way you model it. So with relational, you really only have the one way to access data, SQL query. That's the only way I can access my data. With NoSQL, we have multiple ways to access it, including, ironically, SQL, as I'm going to show you in a second here. But let's start with a key value API. This is common to just about every document database. Every document has a key, so we can perform CRUD operations against our document data with key value API. With a JSON, so with every JSON database is going to have this available. These code examples here are JavaScript, but of course there's SDKs for all kinds of languages, Java, of course, out there, .NET, Ruby, PHP, Go, etc. But the difference here is that this is a API in my coding language of choice. I'm not writing a SQL query to access data, but I do have to have the key to look up that data. And remember earlier we discussed about document size being an issue. So if that's still a concern, I don't want my documents to be huge and unwieldy, and that takes more time to transfer back and forth over the wire, and that's a problem. Yes, I agree. So if you're modeling and you can't or don't want to split up that big document, there's another approach that can help with performance. And it goes by different names depending on the database you're using, but I'm going to call it Subdocument API, because that's what Couchbase calls it. But with this API, you can operate on parts of a JSON document without sending the whole thing back and forth across the wire. So if I just want to change a user status from subscribed to unsubscribed, but I don't want to take the whole 10 megabyte user document back and forth across the wire, I can just update that one field and take that part back and forth across the wire. So that's a good way to operate with large documents, but still have a smaller footprint when I need to. I mentioned earlier that relational's only tool is SQL, and you may have heard that NoSQL actually stands for not only SQL. And with, now I'm getting into specifics with Couchbase. With Couchbase, that is true. For some JSON databases, it's true that it stands for we don't have SQL here. But for Couchbase, it means SQL is an option for you. So Couchbase, full ANSI compliant SQL, by the way. It's not just a looks like SQL, it's a full SQL. Here's some examples up here with joins and group by, aggregates, COM table expressions, windowing functions, CRUD functions, everything you'd expect from a full SQL language is there. I would be remiss if I didn't mention a couple other NoSQL databases. Cosmos DB is Microsoft's Azure offering. They also have a SQL language. It's a much smaller subset, but I do like it because I come from a SQL relational background, like most of you, and I think SQL is a very powerful language. DynamoDB from Amazon also has a SQL implementation. Again, kind of a subset. They don't have joins, for instance, just yet, but those are options there as well. So if your reticence to go to check out NoSQL is the fact that you have to learn a whole new language, I would say it's time for you to check out some of the great SQL implementations for these JSON databases. But notice that once we step out of that key value, that CRUD API, now we have to involve other processes. So we've got to parse the query, most likely use an index service. And in the end, we're going to get a bunch of keys to go look up data from the data service. This is overhead. So when we write a SQL query, we have to add some overhead to it. So this could affect performance. Also, I want to note that many NoSQL databases have their own language that does similar things to SQL, but it's typically a proprietary language. You'll have to learn the ins and outs of that, and it's different than the SQL you're used to with Oracle and Postgres, et cetera. This is a side-by-side that breaks down these two APIs here. This is just two methods to access the same pool of data in a NoSQL database. And so I'm not going to read all these to you, but this is kind of recommendations about which ones you should use for which use cases. So the key value API is simple, extraordinarily fast. This is where you're going to get microsecond latency looking up and writing data. The query API is a lot more flexible, but requires indexing, parsing, overhead. You don't have to do that stuff, but the database has to do a little more work to get that query to execute. By the way, these are just two methods to access data. NoSQL databases will typically have a few more. So maybe a text search engine's built in, or analytics engine, maybe some mobile options as well. I'm not going to cover those today. Here's some more detail on the overhead involved. So you can see the key value over on the left. This is a Couchbase example, but kind of get the point here with any sort of database, is that the key value is very simple. I have the key, go to the data service, give me the data back by the key. On the right side, we've got a SQL query that has to go through all the different steps of a typical query. You're familiar with this if you've ever run sort of any index advisor before, query advisor. You see all those different steps. It's going to engage with multiple services, index service, maybe potentially a search service, and then ultimately, of course, the same data service as the key value uses. But not every operation we want to execute, we know the key ahead of time. So we have options now. And one more here, kind of performance comparison between the two, just kind of reiterating the same things that I just mentioned in terms of latency of the two different operations. So if you want speed, pure speed, stick the key value. If you need more flexibility, bring in query when it makes sense to. Okay, I want to go through some quick samples of data access, how this might affect modeling. So this is the model I'm going to be working with. It's a travel sample model. This is built into Couchbase out of the box, which is why I'm using it nice and easy for me. Airlines have routes. Routes start and end at airports. There's also hotels, which don't have a direct relationship with the others. And these are all in their own collections. So remember, collections are kind of the same level as a table. Suppose we wanted to get an airport by key. You could write a SQL query to do this, just like on the left here. Select star from airport where ID equals whatever. But that involves all the overhead of the SQL engine, the parsing, the index service, et cetera. We could just switch that to, in this case, it's Java on the right, just one Java key lookup. going to be much, much faster. Same thing down here if we want a subset of fields, because no one's writing select star anymore, right? Right, everybody? Okay. You could just select a couple fields instead, and the same thing over here. This is more of the sub-documents API that I talked about. A little more complex to write and a little harder to understand, but it will give you a performance benefit over a full SQL query there. I'm not saying you should avoid SQL. I'm just saying in these cases, we know the key. Let's go to key value API instead. Some key value recommendations. Again, if you want to stick to key value for performance reasons, it's going to benefit you to use as much as possible. Some tips to maximize your key usage, make it easier for you as a developer as well. And this, by the way, this applies to no matter what NoSQL database you're using. These recommendations here, I would go with, keep them natural if possible. Remember that keys are going to be immutable. So if you're going to use natural key, make sure it's not one you're really going to want to change. Human readable if possible, because if I'm browsing data, I know the one on the left is a user, the one on the right could be anything, I don't know. Deterministic, so this is going to help you navigate through. If you don't want to use joins, you can just keep to key lookups. And making them deterministic will help you navigate those. And all these things will make it a semantic key, a key with some meaning to it. Other ways to access data, I've mostly talked about key value in SQL, but I mentioned full text, analytics, mobile, those are other options I'm not going to cover today. But the key here is they all access the same pool of data. I don't need to bring in other services to integrate and copy data between each service. They all go in the same pool. So then it's up to you to pick the right method for your use case. Okay, so I think we're doing okay so far. Let's close with some examples here, just kind of walk you through and show you the pros and cons of some modeling examples. Let's start with this one. So the way I've modeled these, this is, by the way, this is a playlist. You can imagine for Spotify or something, a music service. So I've got a playlist, I've got a user and owner of that playlist, and I've got a song track. So in this case, I've modeled them as 3 separate documents. They'd be in 3 separate collections. And the way I've modeled this is that the playlist there on the left is actually refers to the owner. So I didn't embed the owner, I actually just did a referral. So it's 2 different pieces there. Same thing with tracks. So each track is an array of tracks there, but each one refers to a different track document there. So this is closer to the normalization that you might be used to, except the tracks array, of course. What are some pros and cons of this approach? So potential benefits is in the area of speed, the owner name and the tracks are separate lookups. So that keeps our playlist document a little slimmer. So it's less data we're going to send back and forth across the wire. With queryability here, it's important that our consistency is ensured. It's kind of enforced because there's no embedded copies of data here. So it's basically normalized. If I make a change to Rick Astley's song over there, it's going to be changed for every single playlist that refers to that song. And if Morgan Freeman changes his name, it'll be changed for every playlist that he owns. So that's option 1. That's example 1. Some potential issues with that. Consistency is a potential issue because updates to the track, this is kind of the reverse side of that coin, is that every update to that track is going to update the playlist. So for playlists, that's probably okay, right? But think about an order on an e-commerce site. If I order an item and suddenly that item changes price or description or something, that means that my history is going to reflect that new price. Maybe I want a snapshot of that price when I bought it. So in that case, this model might not be appropriate. And multiple lookups, of course, if I need to get the owner and the track and the playlist, now I've got 3 different documents I need to look up or join potentially in an operation that could be a possible performance issue or complexity issue. Okay, so those are pros and cons of that approach. Let's get a little bit more embedded here. Let's do some denormalizing. So I'm copying some data from the user over to the playlist. Notice there I've got under the owner object, it's not just an ID anymore. Now it contains Morgan Freeman, the name of the owner of this document. It still refers to a separate document, where Morgan Freeman's name is, but I'm making a copy of that to my playlist so that if I access that playlist, I don't need to go look up the owner. It's right there in my playlist. So I'm saving myself a lookup. It's kind of a cache. I'm caching that data in my document. And then, so there's the name there, and then the track is still the same. No changes there. But this will save a join, basically, or save a second lookup. So that's the potential benefit there. Again, with speed, the name is already available, so I don't need to go and look that up again. Queryability means it might just be a single get instead of a more complex join in many situations. What are the drawbacks of this? Well, we know this from relational theory is that, well, for one, speed is potentially an issue because our document's now getting bigger with the user's name in every single document. But consistency is a problem now. What if Morgan Freeman changes his name? Okay, for this case, probably not a big deal. How often does someone change their name? But if it's something more malleable, like, I don't know, an address or a phone number, now we have to go back and update all those other documents with the new data. Now that could be a real issue. So this is probably a good idea if the data doesn't change very much. And then last one, of course, multiple lookups may still be required. If I need something besides the name, I still have to do the second lookup anyway. Okay, the last one is the most extreme example. We're going to embed everything into a single document. So we have one big old document that contains all the owner info, all the playlist info. It's all there in one single document, okay? I don't know if I'd recommend this approach, but it's something we have to think about because it might be a good approach in other use cases. So what are the benefits to this? So speed is the main one. It's just one single lookup to get the entire playlist, user, and tracks from every piece of that playlist in one get operation. Fault tolerance, less can go wrong. I don't have to worry about joins or data being in multiple places in my cluster. It's all one quick lookup. There it is. What are the issues with this one? Document size, of course, much, much bigger. We may need to actually limit the number of tracks in a playlist because, remember, document sizes have a limit. So that could be a potential issue. Consistency, of course, we have multiple copies of the same data. If I have Rick Astley in my playlist, imagine how many others have it in their playlist. Now we've got thousands, hundreds of thousands of copies of that same information in multiple places. Again, depending on the use case, might be okay, but that might be a problem. And of course, queryability, the only thing I can really think of there is potential search issues, right? If I'm searching for Rick Astley, it's going to come up in a bunch of playlists. So I might have to do some filtering or something like that. That's not my main concern with that modeling. But this is kind of the extreme example. And this is kind of where I would, again, want to start with. Embed as much as possible until it doesn't make sense to. And then go back to the normal situation of splitting documents up. So I hope that's helpful. Quick summary here. I would just focus on, if you're looking at data modeling, looking at NoSQL, what's the use case? What's the right application? What's NoSQL going to help you with? One of those four things, accessibility, performance, and availability, and scaling, and flexibility. Do you need any of those things? Okay. Match the data access to your requirements. Are we doing key value? Are we doing query? Are we doing text search? What's the right one? Because we're not back in the days where we only have SQL. Now we have lots of options for interacting with data. And the last one is start with a proof of concept. Maybe a small demo app, or maybe just a small internal app to just give it a first try, give it a first pass, and see what you've learned from that at your organization. And then apply that to a bigger project, and then keep going on that route there. Some next steps, if you want to learn more about Couchbase, I recommend going to the Couchbase Playground, couchbase.live. No installation, just you can run Java code right there in your browser, interacts with Couchbase, you can tweak it, make changes. It's a true playground. Go to town with that. If you want to learn a little more about Couchbase, the next step would be sign up for a free trial. 30 days, no credit card needed. Just go to that second link there and check it out. That last one, I didn't really talk much about migration, but I have an open source tool to help you kind of copy data from SQL to Couchbase and do some of those modeling changes that I discussed there. So that's all I have. I'm happy to take questions now, but first I want to say thank you very much for coming to my session. It's a true honor for you to be in here with me, and I hope you enjoyed Devnexus, and I hope you enjoy the rest of the conference. So what questions do we have? Anything? Kind of hard for me to see out there. Yeah, go ahead. Is Couchbase supported in Azure? Yes, absolutely. So Couchbase, we have a DBaaS offering called Capella. You can deploy it to Azure, deploy it to AWS, deploy it to Google, and of course Couchbase Server can still run on-prem if you want to as well. You can use any combination of those. Is it in the marketplace in Azure? I don't think it's in Azure Marketplace just yet. I think we're working on that, yeah. We just added it to Azure earlier this year, so that'll be coming soon, yeah. I think I saw your hand back there. Yes, you. So the question was, is there any concept of history, like as the document mutates, keeping track of those changes? I don't think we have anything. I don't think any of the databases I know really have that just yet. I think that's an emerging feature that some companies are asking for. Don't know if I can talk about that too much, but maybe, maybe soon. On the roadmap, let's say that. Yeah. Green shirt there. Yeah, so the question was, how does search work on an array? Do you mean a SQL query, or do you mean text search in general? Text search on Couchbase. So I didn't cover text search much today. I didn't think I'd have time for it, but there's a text search engine built into Couchbase. It's, the API is similar to a Lucene type of engine, but it's actually an open source engine written in Go called Blevy. So it's very similar syntax to something like Lucene. And that's, you could create indexes that will search that array. You can define which parts of a document to search, that sort of thing. So. Yeah. Okay, what else? Let's see. I fell over here. Yeah. 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 Yeah, so his question was, we have a large amount of documents in Couchbase, and we change versions, and it takes days to update all those documents in one big bang. So I covered 3 different methods there. One of those might work for you. Where did I have those at? Yeah. So this is what you're doing right now, basically. You're doing a big update. So one thing might help you with some batch processing if you're not doing that already. That might be one way to go. Version numbers is another way. That is adding some data to your record. That might not be the best approach. So if it's possible, this might be an approach you can look at, is do you need to have those all updated immediately? Or can you defer that to when the data is actually used? So that approach might work as well. And I mean, since you're already on Couchbase, let's talk afterward, because we can put you in touch with I have some guys down here that can definitely give you some resources to help with that. So yeah, definitely come up afterwards. Yeah, yeah, right there. Mm-hmm. Yeah. 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 So the question was basically, we're on Oracle for a long time. We'd like to maybe start moving some of the stuff to NoSQL. What's a good migration approach for that? So if I had more time, I'd probably have a bunch more slides about migration. But one approach might be, again, not just a big bang, but let's just cut off a piece of that application that might benefit from one of those 4 things I mentioned. Flexibility, for instance. A user profile may be a great place to start with your application. Let's just try that piece first and migrate a small piece of the data over and start there. And then we can keep going from that point on. There are some great tools. If you come up to me afterwards, I'll give you the name of some tools that can actually do some of these modeling things for you automatically, moving from Oracle over to Couchbase. Yeah. Okay. Are we on time here? I got time for more questions. Who else? All the way in the back. There we go. So the question was modeling with geospatial data. So I'm not sure I've done any, with geospatial data, it's really just, there's like a JSON standard for it. And I mentioned the full text search engine. So we actually have some, with Couchbase specifically, there is some geospatial searches options built into that. So you can do a radius, box, or polygon search based on latitude, longitude, elevation, whatever coordinates with that engine. So you could do that with SQL, sure. It's going to take a lot of math. Key value, very, very difficult, maybe. But again, so the right data access method for that would be the full text search engine. I know that doesn't have geospatial in the name, but full text search has the geospatial capabilities. Yeah. Let's see. This guy's pointing over somewhere over here. Over there. Yeah, sorry. So the question was, SQL Server is not case sensitive. Is that case sensitive? The SQL part of it is case sensitive, yes, because it's based on JSON. JSON is case sensitive. Yeah. Really good question. Okay, what else? Am I missing anybody at the extreme ends? Anybody in the cheap seats up there? How about you in the gray shirt right there? So the question was, does full text search in Couchbase support join indices? Do you mean join in the same sense as SQL joins? Yeah. Yeah. Yes. Okay. So the question is, can I combine documents, even include full text search? So the way I do that in Couchbase is actually the SQL++ engine has a search function built in that will use the full text search engine. So you can combine those two concepts, do a SQL join with full text search. So absolutely yes. Yes. Okay, yeah, right there. Yeah. So the question was, what about partition keys when modeling JSON? I'm happy to say with Couchbase, no need to worry about that. Sharding, partitioning is completely automatic, which is one of my favorite things about it. But absolutely, if you're getting into like Mongo or Cosmos or Cassandra, things like that, partition key is going to be something you have to think about as well, because that's going to affect performance. Yes, absolutely. Yeah, something I don't think about too much, sadly. So, yeah, that can be a challenging thing to work on. Maybe one more quick one, then I'll get off the stage. One down here. Okay, last one. Yeah. So it's not CouchDB, first of all, it's Couchbase. I know it's a common mistake, that's okay. Just kind of a pet peeve of mine, sorry. Comparison between full text search and Elastic. Like I said, Elastic uses leucine, and the syntax for the Couchbase one is very similar. I guess my concern would be, is it Elastic on its own? I think we could have a pretty good comparison between the two. If you bring in things like Logstash and Kibana, it gets a little more complicated, the whole Elastic system. In any case, Couchbase does have a connector. So if you want to use Couchbase and Elastic together, you can do that. Yeah. Yeah. All right. Thank you very much, everybody. Have a good rest of the conference.